Good morning. Today we are going to be talking about some properties of addition. Now, all mathematical properties are statements that are true whatever the values are that you're working with. And sometimes mathematical properties are referred to as identities. In this very brief lecture, we're just going to be talking about properties of addition. We also have similar properties in multiplication, basically the same, but when you get to division and to subtraction, those properties change. So right now we're just going to be talking about properties of addition. But before we begin, can you tell me why it is that the horse crossed the road? We know why the chicken crossed the road, but the horse crossed the road because he wanted to get to his neighborhood. So anyway, moving right along, we have the commutative property of addition, associative property of addition, additive identity, and additive inverse. These are the main properties of addition that we're going to be talking about right now. Now first, the commutative property says that it doesn't matter in what order you add numbers together. If you have 3 plus 5, that's exactly the same as 5 plus 3. Doesn't matter what order you add those two numbers together, you're going to come back and always arrive at 8. That's the commutative property of addition. It says the way in which you add your numbers together makes no difference to the result or to the outcome. And of course, since in algebra we're learning to use letters to represent any number at all, and those letters are what we call variables, we can write a picture using variables of the commutative property by saying if we have any two numbers, a and b, any two values, a and b, we can say a plus b is the same as b plus a. It doesn't matter who's first. When we're young, it really matters who's first. Everybody wants to be the line leader. Everybody wants to be able to pick the biggest cookie. With the commutative property of addition, it doesn't matter who's first. Second property that we have is the associative property of addition. Now, if I said that the answer to 2 plus 3 plus 4 plus 5 was equal to 14, that's not because I added all four numbers together at the same time, or if I said 1 plus 2 plus 3 was 6. The more familiar you get with doing arithmetic and calculations in your head, the easier it is for you to look at a column of figures and give what the sum is, or the difference, or the product. But you're still only adding two numbers at a time. It's different from if you're making a cake or making cookies. And when you're making a cake, some of the very common things that you'll do is you'll put butter and sugar and eggs together, get your beater or your mixer, mix that all up together. You're not first mixing together the eggs and the butter and then adding the sugar. At least if you cook the way I do, you dump all three of them in, you mix them all up together. That's different than what we do with addition. If I say 1 plus 2 plus 3, first I can say, well, I know that 1 plus 2 is equal to 3. And I know that 3 plus 3 then is equal to 6. So in other words, I've combined the 1 and 2 together, or I've added 1 and 2 together first to get 3. Then I add the third number, which is a 3, to get my result of 6. But I could just as easily have combined the 2 and the 3, which would give me 1 plus 5, which of course is equal to 6. So, just like when you're making a cake, it doesn't matter if you first mix the eggs and the butter together, and then the sugar, or you mix the butter and the eggs together, and then add the sugar. When you get it all combined, you always end up with the same result, which is delicious cookie dough. Here, it doesn't matter the order in which you group your numbers together, your values together in addition, because you always end up with the same result. Once again, we're using algebra where we're taking something that's true for one specific case, and because it's true for every case, we can use letters or variables to express that idea. So what we have here is A plus the quantity B plus C is going to be equal to, or is going to have the same value as the quantity A plus B plus C. Let's just go ahead and put addition back here in blue. When you have values that are inside of parentheses like this, did you notice how I read it? I said A plus the quantity B plus C. The quantity is how we pronounce parentheses when we're reading this. So A plus the quantity B plus C is equal to, or has the same value as, the quantity of A plus B plus C. All this means is when you're adding three numbers together, it doesn't matter which two numbers you group together first. And you did a lot of working like this when you were in elementary school math. That's when you learned to do grouping, convenient grouping. For example, if you had 25 plus 18 plus 75, as you worked with recognizing tens and hundreds, you can see, oh, 25 plus 75 is 100 plus 18 is equal to 118. And that became an easy way for you to look for convenient combinations of numbers. Instead of saying, okay, 25 plus 18 is 43 plus 75, and then 43 plus 75 was equal to 118. Got the same result, but it was a lot quicker when you could recognize convenient patterns to add together. So that's the value of having this associative property of addition. The third property that we're talking about is the additive identity property, and what this says is if you start off with any number and you add 0 to that number, you have not changed the value of that number. And you're thinking, well, that's like really obvious. If I have $2 and you don't give me any more dollars, and I still have $2. If you have 10 M&Ms and you don't get any more M&Ms, you still have 10 M&Ms. If you start off with a number and you add nothing to it, you haven't changed. So 7 plus 0 is equal to 7. And once again, the algebraic representation of that is you start off with any number, whatever it is. And if you add nothing to that, A plus 0, that's still equal to A. And you might think, well, that's very obvious, and it is. But you'll use interesting ways to express 0 that you'll use this property to help you later in algebra. Finally, we have the additive inverse, and we've talked about how if you add a number and its opposite, you always get 0. 3 plus the opposite of 3, 3 plus a negative 3 is equal to 0. Negative 3 plus 3 is equal to 0. If you take a number and you add its opposite, or you take the inverse of that number, when you combine those two together, you always get 0. So that says if we take a number and we add its opposite, remember we've talked about how the negative sign can be read minus, negative, or the opposite of. So what we have here says if we have A plus the opposite of A, that result is always going to be equal to 0. So that's the conclusion of this lecture. We have 4 properties. We have the commutative property of addition, says it doesn't matter. 2 plus 3 is the same as 3 plus 2. The order in which you add numbers does not affect the outcome. The associative property says that grouping doesn't matter. Doesn't matter how you choose and what sequence you choose to add numbers together, you're going to get the same result. The additive identity, of course, says if you start with a number, you add nothing to it, you haven't changed the value of your number. You start with a long equation, you add nothing to it, you have not changed the value of that equation. And that will come in very useful much later in the course of Algebra 1. Finally, the additive inverse says that if you take a quantity and add the opposite of it, or add its inverse, that you always end up with a final result of 0. So that's what we have today for our properties of addition.